Hello and welcome to this video about remote method invocation. So this is our second client server technology. Remote method invocation, or RMI, is used to make two programs talk to each other. So this is the plan for this video: a short introduction about what is RMI and what's the idea behind it, because it is slightly different than sockets. We will see how we set it up. So when we did the socket connection, you had to create a server socket and you had to accept the connection and create sockets on the client side. So similarly with RMI, there are a few steps that we need to go through to create this connection. And then we're going to look at some code examples. We have different approaches and different ways of using RMI, so we will go through 4 different small programs, our usual uppercase example. And then there is something about security which we don't really care about, but we still have to include it when we do the program. So we have seen sockets, a way to connect a client and a server, and this is about remote method invocation, or RMI, which is, in essence achieving the same task but in a different way. So again, we want to make a client program communicate with the server program. So what is RMI and what's the purpose of it? And the idea is that we want to instantiate objects on one computer. So here I create a server object, and then I want to be able to call methods directly on this object from my client program. So we have this piece of code here, which we will see again later, but basically I make a connection to the server, and then directly on the server class, that's at least what it looks like. There's something going on behind the scenes that we will also discuss in a little while, but it looks like I'm just calling a normal method directly on the server. So it adds an extra abstraction layer compared to sockets. When we did the sockets, we would have to read some kind of request from the client. At least this is my approach. You could do something different. And then we would have to do a bunch of if else to figure out what method is it that I want to call on the server. So we just had this one bridge, you might call it, from one stream on the client side to one stream on the server side, and this is how we handle it. So you don't have the same level of control as we usually do when we just call methods on objects, but that's what we achieved with RMI. So with RMI I can have a client and I can directly call a to uppercase method or to lowercase, random case, camel case, whatever. So instead of just sending the object and then the server would have to figure out what is it actually we need to do with that object, the client will now call a method directly on the server. So it's a bit more clear what's going on. We don't have to handle the let's call it low-level method invocation like this. We can just call methods directly. Right, so RMI provides a higher abstraction level. It also uses TCP connections, and a lot of the communication behind RMI is hidden from the programmer. So when we did the sockets, we would have the streams, the input and output streams, and we would send objects using those streams. And RMI is essentially doing something similar, but all that is hidden from us, so we don't really know what's going on. Another limitation is that client and server must be both written in Java. RMI is a Java framework. If you use sockets, then you can connect programs from different programming languages. In your third semester you will be doing C# and Java together, and you can use sockets to connect those. But RMI is just for Java. And then one of the benefits of this high abstraction level is also that we don't need to worry about multi-threading explicitly. When we did the sockets, for each client connected, I would have to create a new socket handler, a separate thread, and that would handle that specific client. But RMI handles the multi-threading for us. Now the documentation is not super specific about how it works, and not even if multi-threading is always used. It says something about it's sometimes used. So we still have to worry about synchronization on the server and potentially the client parts, but we don't have to explicitly create threads. So this is what it looks like when we do the sockets. I had a client program and it would create that separate thread, a client socket handler in my case, and the server would also create a separate thread. So a lot of the communication is going on through these threads here. And we do actually have something similar with RMI. It's just hidden from us. So we do have some separate threads or similar going on behind the scenes, but we don't really see that. That's part of the RMI framework. And what it looks like is just that the client has a direct reference to the server. And then there is something going on down here. If you use the debugging tool, then you can see there are some proxy classes instantiated if you want to investigate. So the setup is sort of similar to the sockets, but we just don't see most of it. So that's the idea of RMI. Basically, we just want to call methods on the server as if the server was a local object that we can call methods on, as we usually do. Alright, that's the introduction. I hope you sort of get the idea. We just want to call methods directly on the server object. Alright, so there are some concepts we need to understand when we set this up. A couple of steps to go through. So I have my client computer and I have my server computer. And on the client computer we have a client program running, and over here we have a server program running. And the first thing the server program will do is to create something called a registry. You can consider it sort of like a phone book. You don't know about maps yet, but that's a Java collection similar to ArrayList, but with slightly different functionality. So, but the registry is sort of like a phone book. The idea is that we can look things up in the registry. So we start the server program from the main method, and it will instantiate the server object, and it will create the registry, and then the server object is put into the registry. Then the client program can start. So that's basically starting the server. Now we have created our server socket, you might say, and we are waiting for the connection. So now the client program starts. It will contact the registry. From here it will look up what it needs, sort of like the phone book. And what it needs would be my server program. I can put multiple objects into the registry. So it will look up a server object, and it will receive what we call a stub. So a stub is an interface that represents the server object. The server object will have to implement this stub, this interface. So that's what we get from the registry. I get an interface back again. And that's our local representation of the server. So this interface is what I call the methods on. And then because of the RMI setup, the method I call on the interface over here is actually called on the object over here. So once we have the stub, the client can now invoke methods remotely on the server object. Right? So we instantiate the server object, we put it into the registry. The client can get the stub representing the server object, and then using that stub we can call methods on the server. Those are the steps that we have to go through to set it up. Now, that's the concept. There's also something specific about the code that we must do. So there is a special interface that we must implement if we want our object to be remotely available. That's the remote interface. All the methods in this interface must be defined to throws remote exception. The server must have a constructor in which it does a specific call so that it exports itself to be available for remote method invocation. When we start the server, we create the registry, create the server instance of the type of its interface, and we must add it to the registry. and then the client can access this registry. So this server interface here is the important point, and we will see that in a little bit when we do the code example, which happens just about here. So the first example is just the uppercase example. We have a client which can send a string to the server, and the server will change it to be uppercase and then send the result back again. So my super simple program looks like this. Well, that's a screenshot. I shouldn't have selected that. Didn't notice. Okay, so I have this is my server part. Right, I have a server package and I have a client package and I have a shared package. And then in the shared package I have put my server interface. This is the interface that the server must implement and that the client knows about and represents the server. So because they both need to use it by implementing or association, I've put that in the shared. And as you can see, the server interface here, it extends remote, and my method here is defined to throws remote exception. So this method is implemented in my server. So my client can get access to this interface, call the method on it, and because of the RMI proxies going on behind the scene, this method is then actually called on the server object. So let's try this out. I have my new project here. I'm doing 4 examples, so this is the first one. I call it uppercase return. I will put it all on GitHub again as usual so you can see it. We create a client package. I create a server package and I want to move that to here. I create a shared package like that and it goes in here. Yes, refactor. Okay, so that's my setup. We'll do the interface first. That's the only one that doesn't have, so let me just find the, that's not it. Return. Come on, okay. Right, so the interface is the only thing that doesn't depend on anything else, so that's a good place to start because I can create this without having any compile errors. So let's do the interface. I want to call it uppercase server and it's an interface like that, right? And it must extends remote, right? From the Java RMI like that. And I define the method called toUppercase, which takes a string argument and returns a string value here. So we say string to uppercase string like that and throws remote exception. Now if you don't put this in here, you will get an exception about an invalid interface. Maybe I remember to show you that. I'll just remove that so we can see what happens. Alright, we'll do the server. So I need a server implementation like this. Server impl, and it must implement the interface uppercase server like that, which also means that I must implement the method. Yeah. We can just finish that one. So we just return string to uppercase. There we go. Right, super simple. And then the server must have a specific constructor where I export the server object so that is remotely available. And we do like this. I need a constructor, and we have unicast remote object export object, and I want to export this object. And the 0 here is a port number, so we just use the default port. And I want to add exceptions like that. Now I could actually do this outside. It's just I want to export this object. I could do it from somewhere else as well. I just have a tradition of doing it here. Okay, so that's my server. It's fairly simple. It implements the interface which represents all the methods that the client can call on it, and it exports itself so that is available for the remote method invocation, and we have the functionality to return an uppercase string. Now I want to start my server. In my class diagram, I have a main method here to start the server, and this is also where we have to do the registry thing. So I create a run server, and I need a main method, and I will create a uppercase server, and that's equal to a new server input, like that. And we should just, it doesn't really matter whether I surround with or throws here. So we just do it like this. If the server cannot create itself, then the program will basically crash. Okay, I need to create a registry, Java RMI registry. Hang on. I just needed to refresh my memory, so it's called a locate registry. And I want to create a registry, and here I give it the port number, and apparently 1099 is the default RMI port, and if you use something else it might not work. When we did the sockets, you could basically use anything. Sockets was pretty forgiving on that part, but for RMI you might as well just stick to this one, then it should work. Okay, so this one creates a registry for me. So that's my phone book, and I want to put my server into this. So the registry I want to bind, and I give my server a name. I just call it server. I can give it any name I want to, and I put my server here. And then we need to so the idea is that when the client wants to look up and get the server object, it needs to get it by a name, and this is now the name of my server object. I could also call it uppercase server or whatever. It doesn't matter what I call it here. It's just that my client must know about this name and use the same name. And then we can just print out server started. So these are the steps, right? Create my server instance, create my registry, and put my server into the registry. And just like we had here, right? Server program, and we put it into the registry. And then the next part is to make the client program, connect to it, and retrieve the stub, which is the interface that represents my server. Okay, so this would be my stub, right? Interface that represents my server. So we do the client side. I need a I don't know, I call it RMI client, and here I need, let's just see my class diagram. I do have a constructor. I don't really need an explicit one, but let's just create it. Oh yeah, I do need it, sorry. So we do create it, and then I want to create a method which will take a string and send that to the server and return it again to me. So we say public string to uppercase string argument, whatever. Okay, and for now we'll just return nothing. So in the constructor here I will make the connection to the server. So we do something similar. We say locate registry, and I want to get a registry, and I want to get it at a localhost IP and a port number 1099, like that. And this one could go wrong. We just add it here, and it returns to me a registry. And then on that registry we say lookup, and this is where I have to give it the name of my server, and the name of my server was server, how original. And that can also throw an exception, and we just add that here. and by default it will give me a remote because that's what I'm getting, and actually I'm getting this interface, but it extends remote, so I just need to cast it to be an uppercase server like that. And then I actually don't want to define it as a local variable because I'm going to need it down here. So I will create a field variable like that. All right, so when I start my client, it is creating the connection. If we want to stick to the convention I started with sockets, we would actually have a start client method. So let's just do that like that, and it cannot be final. There we go. Okay, and then well, this method here is used by the rest of my client-side program. So we want to send something to the server. We say server to uppercase with argument, and that returns a string to me, result, and I can then return that result like that. All right. Yeah, we'll get back to this because I actually do need a try catch here, but because to uppercase I removed the throws remote exception because I want to show you what happens. So if you get that error, hopefully you will you'll remember what you need to do. So we'll fix this part. It's not entirely correct yet, but we will fix it when I get the problem. So that is my client for now, and I will just create a main method. So run client, and here I will create an RMI client, new client, and we start the client, and I can just add the right. If my client cannot start, maybe in this case my program will crash. I could otherwise, try to wait 5 seconds and reconnect to the server or something like that, show a message to the user, but we will skip that for now. All right, then I want to be able to read something from my keyboard and send that to the client, which will send it to the server and get a result back. We go system.in like that, and while let's say string read equals ignore case. So as long as I am not writing exit, so let's see, in.read line, next line, I will just put here input. This one will give me a string. I call it line. Yeah, maybe I'll just do like this and check here if line equals exit, then we want to break. Otherwise we get I use my client to say to uppercase with my line, so I'm giving the input to my client, and this will control Q, it will return a string to me, result, and I will print that out, result, like that. So I can just keep writing stuff to my client. I don't need to have that. Okay, so that's my program. Let's try it out. I need to run my server. Not like that. Go away. Run server. And already here it fails. So I have something about remote object implements illegal remote interface. Right, so that's what I mentioned too. Illegal remote interface. If you get this one, there's something wrong with your server interface. And this is my server interface. and it's illegal, which means that it either does not extend remote, which mine does, or it does not declare the throws here. So throws remote exception like that, and that means I have to fix something in my client. Not here. Here you see that it now. So here I don't want to throw an exception. I want to surround with a try catch, and I could print something out, and then we could just return error, or I could either return that, or I could throw new runtime exception. Could not contact server. Right, but the point here is that I should not just throw my remote exception. If you remember my layered structure for the client server system, then each layer should sort of be isolated. And if I throw the remote exception, then my MVVM model will probably have to handle that, and it means that my model knows that there's an RMI client beneath and not a socket client. So I don't want to make that bleed through the layers of my system. So I catch the remote exception, I can throw a runtime exception, because that's just a standard exception. It doesn't indicate whether it's sockets or RMI or anything. So and then in here we might want to try catch this one, and if I catch an exception, I can print out error and get message. So I will actually show something to the user. So I try to contact the server. If it succeeds, I print out the result. If it doesn't, then we print out the error. So let's try again and see. I'll try to remember to get the error here as well. Right, so the illegal remote interface, it means there's something wrong with your interface. It doesn't extend remote, or it doesn't throws the remote exception. So my server is started, and we run the client. And it's connected. Hello. And I actually get a result back. Blah blah again. And I can write exit, and that terminates. So my server can actually, let's just see that. My server can by default handle multiple clients, because it already does that multi-threading behind the scenes, or at least as much as it needs to. So I can actually have multiple clients running. So this one is ready for input. Right, so it's obviously connected to the server and interacting with it. And if I run another one, there we go. This one is also interacting. Right, so they're both running, and I don't need to manually handle that multi-threading part. Okay, so let's terminate this one. Exit. And now I want to terminate my server and try to contact it, which will give me this error message here, hopefully. Let's see, I terminate this one. Now my client doesn't say there's anything wrong yet. Are you still there? And I probably get a timeout. Right, so I do still print out in here. I print out the stack trace. You can decide whether you want to do that or not, but it gives you an indication of where the error happens. But I do actually get the error could not contact server. Right, so this is what the user would see in the GUI, for example. All right, so I think that's all for this example. Let me just terminate everything. I have my here and a laser pointer. So I have my client server set up, and it's basically the hello world version of client server setups. It's super simple. I couldn't make it smaller, but we can send a string to the server, and it will return a result back to us. And that should be it for this example. Right. So the main parts is the registry thing, putting the server into it, creating the interface and following the rules about the throws remote exception and the remote interface here, extending it, and then the client can call methods on the stop. So just to again to flesh that out, right, this here, that's the interface representing the server on the client side. This is my stop. Right. Okay, so let us move on to the next part. We did that. I'm now typing in I don't know. Okay, so we did the uppercase. Now there's something called callbacks, and back when we had the client server using sockets, I would send something to the server, and the server would someday later, sometime perhaps, maybe not a day, it would return something to me, but it will not be as back and forth right away. So I would send something to the server in one method, and then I would get something back in another method. So that was asynchronous. I did show an example of how to do it sort of synchronously as well, but and that's what we are doing so far in RMI. We're doing it synchronously, but I can also make a callback. Say I want to send something to the server, and then the server will do some super heavy calculation or access the database or whatever, and then when it's ready, it will call a method on the client to say, hey, here's your result. So it's not a return value, it's we're calling a method on the client. So that's the callback part. We are making a call back to the client again. So that's the next step, and that will lead us to the broadcast functionality that we have seen in sockets, that the server can call methods on multiple clients to notify them and update them about stuff going on the server. So the next example is about, well, basically doing the same uppercase but using a callback for that instead, just to see how it works. And this is my previous setup. Yeah, just we could call a method on the server, it took an argument and returned something. And the new setup is that now I also need a stop representing the client so that the server can call methods on the client. So we need a similar setup. I don't need the registry. The registry is only used for the initial connection, and I have that now. But then we need the interfaces so that the client can call methods on the server, and the server can call methods on the client. So the idea is that the client, when we get the to uppercase here, when this method is called, you see that it's now void. It will call a method on the server, also void. The method will, here on the server, will convert it, and then it will call a method on the client. So this is the way we send it back. You see the client now sends itself along an argument of type uppercase client, this one here. And then the uppercase result is called on the client, and we can print it out. So we sort of have this crisscross thing going on. Client calls a method on the server will call a method on the client, and then so let's just to see it in a bigger. Now I have said everything, so I hope you saw it in the previous slide. So that means at some point my client here receives something from the server, and we could make it a subject that my class here listens to this one to react to it. So this class here represents the model in a larger program using MVVM, and the model would listen to the client. I'm not doing that for now. I hope you can figure that out yourself. So I'll just print it out in the client this time instead, whenever I get a result. Okay, so let's change the previous program to use a callback system. So I don't know what's going wrong with my guy over here. It seems like he's slamming the keyboard rather than actually typing something. So this is a more desperate approach, hacking away until something works. I see my students doing this sometime. At some point I will maybe make him smash his head down into the keyboard as well. I don't know. Bit of a sidetrack. So let's create a new program here. I'll just shut down all this blah blah blah. Away with you. I will create a uppercase callback. So I can already now see that this is becoming a bit of a lengthy video. So I'll just copy all this to make it a bit faster. And let me just find the other diagram, uppercase callback, this one. Right, so most of it is the same. I need to modify this method signature here. Let's start with that. No, I don't have the uppercase client. So let's start over here. Make my client a remote object. Right, I call it a remote object because the method, the server can now call methods on it. Similar, my server is also a remote object. So we'll start here. I put the uppercase client in the shared package and create a uppercase client, an interface, and the method is uppercase result. Right. So similar to the when I want to make this remote, I need to extend remote like that. Yeah. Come on. Import. Yep. And we have void uppercase result string result, and it throws remote exception, right? Otherwise my interface will be illegal, and I will get that exception that we saw previously. Okay, so now I can modify this one. It no longer returns a string, it's a void, but it takes an argument of type uppercase client. Client. There we go. My client here must be made into a remote object. So I have to implement the object here, implement the interface, uppercase client. I implement the method like that. So the uppercase here, we change that to be void. There's no result. And the uppercase argument. Now this one here, it takes also an uppercase client, right? So that's this takes my client itself, and it doesn't return anything like that. There's no result. So I just send a request to the server and say, hey, do something, and here's myself. You can poke with the result when you're ready to do it. I don't want that, right? So this should never be declared to throw. I know when you auto implement from the interface, you will also get it here, but you should always remove it, because otherwise the model or my main method using this one will have to handle the remote exception. And as I mentioned, we don't want these IMI specific things to bleed through my layers to my model layer. So I just remove that, and I can do that because the remote exception is I don't know, I can do it. So okay, so I need to remember to export my client. It's not enough just to do the interface. I have to export it just like I did with the server. So we say unicast remote object export this, and on the default port. Not entirely, documentation just says default port, so I guess it's just using whatever I set up somewhere else, the 1099, which I did over here. So now this one throws remote exception, and that's okay. It will crash my program. Okay, I no longer get my result back. So this is where I would add myself as a listener to the IMI client. If I wanted to have a observer set up, I'll just skip that for now. So in my client here, I need to just print this out, result. So from the user's point of view, it should look the same. The point of making it a callback instead of a synchronous call where we return something is that if it's a long method call, if you need to do something with a database that takes several seconds, then if you just do it as a synchronous call, like this part over here, synchronous call, then your client is frozen and stuck, And if it takes more than 10 seconds, then most users will get impatient and start mashing buttons and seeing why is my program frozen, and then they will terminate, and they don't really know that it's because the server is working on a result. If you do this here, then your client is still running and interactable, and it will just update itself once it gets a result from the server. So this asynchronous call is a very common approach in client-server systems. Right. So I think that's all again. So let's try and run my server. Oh, I still need something here in my server. This one here. Right now I need to modify my interface. So we say uppercase client. So, and this is now void. So instead of returning something, I have a string result like that. Uppercase client. Import class. That's good. Okay, and now I can tell the client, hey, so let's say assume that a heavy calculation here. Right, I could say thread.sleep. I could attempt at least sleep and say 2 seconds just to simulate that it takes some time. Try catch. I don't want to do anything here. Okay, and then once we are ready, I have now contacted my database or whatever we're doing, made a heavy calculation that was very time consuming, and then now we're ready with the result, and we say client, hey, I got your result, here you go. And this one could potentially go wrong if my connection to the client, if the client terminated because my user got impatient and shut down the program. So again, here I have to surround with a try catch. And I could print out a stack trace. That's probably fine. There's no user on the server side to give a message to. So that's my catch, empty catch block. Okay, that's very nitpicky. Anyway, let's try and run the program again. So that was the major changes, right? My server now receives a stub of the client, a representation of the client, and we can make a callback to the client at a later point in time. So it's no longer synchronous, which was when we just returned something. It's now asynchronous, so we don't return something, we just make a call to the client whenever we are ready. Run server. All right, that's my server. Run client. There we go. Hello. And I'm waiting about 2 seconds, and then hopefully I get a response back. Now, as I mentioned, my client just prints out the result. This is where I would fire an event using the observer pattern, my support, property change support, so that the model represented by my run client method, my main method here, could react to it. All right, I can just hello again. Okay, so my client is working, we're using the callback, and I just want to show something here. Instead of 2 seconds, we go 10 seconds, and then just again to make it clear that my server is actually handling multiple clients. So I want to run one client, and then I run another client, and then I see if I'm fast enough to type 2 hellos, and we will see that they are both getting a result back. So maybe I will not write hello, I'll do it like this. Okay, so now we're both waiting for the result, and it should come back over here about, I don't know, 5, 4, 3, 2, 1. There we go. Oh, that was a pretty good time. So I get a result back, and I also got one back here. So my server here is actually handling 2 clients at a time. Okay. Let's stop all this again. So that was my callback. And just put that over here. And make that big again. There we go. Okay, and let me find a list pointer. So the callback, right? The client can call a method on the server, and the server will then call a method on the client. So it's now asynchronous, and often that can lead to a better user experience because your program does not freeze, but also it will lead us to the next step, which is the broadcast. So if you're doing the chat system, instead of just calling back to one client, I want to call back to all the connected clients so they can all see the chat. So I've done that, and we're then moving on to the broadcast, meaning that we do callbacks on all the connected clients. So in our case, when one client to uppercase something on the server will send that back to all the connected clients, and they will all print it out. Right, so this is what it previously looked like. Client could call the method here and send itself to get a callback. What we want to do next is that the client can register itself and say, hey, I want to be able to get updates whenever the server thinks there should be an update. Right, so now my server has a list of uppercase clients, and whenever one client calls the toUppercase method, we will make callbacks on all the clients. So otherwise I don't need to modify the client much. I have made it back here to uppercase so that it's a synchronous call, and then the update happens on all the others. Okay, let's see how this goes. So again, I will make a new package. We call it uppercase broadcast, and I will steal the callback. Will I? No, I will not. I will steal this one here, because it was not the callback. I needed the return method and add a different type of callback. All right, so let's see. According to my diagram, let's just find the right one again, broadcast. I have the toUppercase, takes a string, a client, and a string. Oh, that was the other callback, uppercase call. Yeah, so that's synchronous. It returns a string. So let's fix this part first. Not that one. My example. Client server shared. In here, uppercase server. So I have this one. It now returns a string again. And I also have a void register client, and it takes an uppercase client to register. And also throws remote exception. Like that. Let's go to the server and fix this part. So this now returns a string, and I don't want to wait 10 seconds. Let's just do 1, and then down here, instead of doing that, we will say return result, like that. Okay, I also need the register client thing method. There we go. And again, you see, if I auto implement, I get this part here. I don't want that. I need a list of my uppercase clients for broadcast. I'll just instantiate it in here. Clients for broadcast equals new lists. Okay, so whenever a client wants to register itself, we just say clients for broadcast. Nope, clients for broadcast, that one. Add client to register. So now I have a list of all the connected clients. Whenever we get the result here, I want to broadcast it. So we say for each, I just do like that, update clients with the result. So I create a different method. Okay, and we say for each not like that, clients for broadcast, client, and we say client, and this is where I need the update method, right? So my client should have an update method instead. So let's just fix that one. Uppercase client, we call it update, takes a result, that's good. Let's just see, I did fix it down here. Broadcasted. Okay, so back on my server, we say client update with the result. So now, and we want to do a try catch here. Now the question is, should I do a try catch around the for loop or around the inner thing here? And I will do it around the inner part, because if I am trying to send something to one client and it fails, I want to go to the next client and also try to send that one. If I have 10 clients connected, then one of them may disconnect, but I still want to send to the others. If I move the try catch outside of the for loop, then the first time if the first client failed, it would skip out of the for loop, and then the other clients will not get an update. So here we put it inside. So for each of the clients, we want to try catch that. Okay, I could probably do something, I'm not entirely sure, because obviously I don't want to, I don't know if it's obvious, but I probably don't want to send this result back to the client that made the initial call, because it already gets the result. So I only want to notify everyone else. And I do think if I just do like this, if client equals, so we can add this one, don't client, and we call it don't broadcast to me. If it equals that one, we will skip it, but I do think that this will not work. We'll see how it goes. But I add a client's stub down here, and I also get a stub down up here, but it's probably not the same stub on the server side. It's like you can still have several socket handlers connected to the same client, but the socket handlers are not the same. So I don't know if that makes sense. We'll see if this works, and I guess it don't, and it doesn't. Okay, so that's the server part. We can register a client, it's kept track of, and whenever a client to uppercase or something, we broadcast it. I have updated that one, so I just need to fix my uppercase client implementation. And let's see, uppercase client, this one here. So uppercase, I actually get a result back now again, string result, that, and I could actually return it now, string return result. And let's go to the run client. Now I get a string result, and I want to print out the result. Okay. So read something from the console, we send it to the client, which sends it to the server, which gets the result back, which gives it here, and we print it out. And the server will also broadcast to all the other connected clients. So I think I have everything in place. Call a method on the server. The server will return something to the client, return value, but it will also call on all connected clients the update method. So let's see how it works. Run server. That was the server. Run client. And we say hello, and we wait a second, and I actually just get the, oh, that's because I forgot to register the client. So let's just shut down everything, and we say the RMI client. Once we have the server, I want to say server register client, this. So now I also register my client to listen to the server. Let's try again. And there we go, hello, and we'll wait, and I get a response back, but there's no broadcast. That's actually a surprise to me. Maybe it works better than expected. Okay, let's try and say run another client. Okay, yeah, I need to do the usual thing. There we go, so I can run multiple instances of it, run client. Okay, we'll say broadcast or hello other client. And I get that back. And I actually get a broadcast here. That's wonderful. So happy. Hello. Get a hello back. And over here I get a hello broadcasted. Wonderful. So I have made a super boring chat system. So that's good. That works. That was better than expected. I definitely didn't think that the this part would actually work, but that's nice. Okay, so there was this set up here. Now I have the synchronous return value here, but I also have the asynchronous updating. Oh, sorry, not that, the update over here. So I can send messages to everyone else, and I can register clients, and I could also create a deregister, which would remove the client from the list if I wanted to do that. So let us move on. Let's see. That was the broadcast example. And then I have a comment about sending data versus sending functionality, because as you have seen with RMI, I have a bit more control. You might say I can call specific methods on my server interface, and I can actually have multiple server interfaces. So that's the next part. So sending data versus sending functionality. Right, I have just sent strings so far, but I can also send our usual data containers that we did with sockets, as long as that one is serializable. So if I had a message class, it must implement serializable, and I can send the data container. So data containers are what we usually send back and forth, not strings or something else. You send a container, a small object that contains some data, and it must be serializable. But when we use RMI, I can also send remote objects. I have sent my client along with a method call, but I could also request another server instance. Right, so my remote objects are something that represents an object in a remote environment. If I send a client interface, it represents a client object on a different computer. This one here will create a clone or copy of an object that you sent, so there's no connection between the version of this object on the server side and the version that the client side receives, or vice versa. But the remote object will have the connection between the client and the server. So this one represents an object on a different computer. So there's a very important distinction between the two here. If you have something that implements a remote interface and also a serializable interface, it will sort of downgrade itself to just be serializable. So serializable will override the remote. At least sometimes. I've seen various versions of it, but never implement both of these. It will just mess up your program, and there's no need to. You should never need to. But I've seen it done sometimes because some students said, but my program complained that I had to do it, and no, never both of them. Okay, so previously my client sent a representation of myself. That was the callback or the register client. So the server can actually do the same. So that's the sending data. I just send a string, but I could also send a message object or a request object like we did with the sockets. But I could also send functionality, which was when I sent the client interface. So I sent something the server could call methods on, and we can do the other way around. So I don't know if you've heard about solid principles yet, but it's about single responsibility and interface segregation, meaning that if I had previously I had a server that could to uppercase something, and we might consider that one responsibility. If I also had the option to lowercase something, maybe we could consider that to be a different responsibility, and instead of putting it all into one server object, I could have two server objects, so that if you do this for the semester project, one can do the functionality of to uppercase, another can do the functionality of to lowercase, and obviously those in this case are so simple that it doesn't require two persons, but for the semester project your functionality might be a lot more complicated. So maybe it's about updating users and updating car reservations or whatever. So we can do this here. I can create an interface that's responsible for, oh, this one should not be here. Hang on. Okay, quick fix. So now I have an interface that provides the functionality of uppercasing something, and I have an interface that provides the functionality of lowercasing something. And they're currently used by the same client, but I could also have multiple clients. For sockets we just had that one client because that made most sense. But I could actually split them out in sockets too. But here I could have a client that uses the uppercase because I have one view for uppercase functionality. So one view and one view model and one client and one server interface. So I can have an entire vertical cut that's just dedicated to uppercase. I can do the same for lowercase. And then I can create a server interface that can retrieve the other server interfaces so that the client can get access to different types of functionality here. So instead of using the registry to look up the server and the uppercase interface and the lowercase interface, I will just look up one of them and then use that interface to retrieve the others. That's the usual approach. So we use the registry as little as possible. The registry is just a bootstrap to get started. So let's try out this example here. Come on, there we go. Hello IntelliJ. Okay, and I'll create a upper and lower, and I will create a which one should I steal? We will just steal the first one here, uppercase return, so that's the simple one, like that. All right, so let's see. I need to have a server interface, so that's new. Let's but this one, you see, that actually depends on me having an uppercase and a lowercase. So I will fix these two interfaces first. So uppercase server, let's see, does that look right in the shared? Uppercase server. I can to uppercase something. I don't need the callback. Didn't I take the return, uppercase return? Interesting. Okay, I don't know. So uppercase server, I don't need the callback, but I do need to return a string like that. I also need a lowercase server interface. It extends remote. It has a string to lowercase, and it takes an argument, and it throws remote exception like that. And I need the server interface, and also this one extends remote. And I have a uppercase server, get uppercase server, throws remote exception, and I also have a lowercase server, get lowercase server. Right, so in my diagram, that's this part. I have this interface and I have that interface. I need my server implementation next. Let's fix that one. So my server impl, instead of that we implement the server interface, and I'll just remove this one. Okay, we need to implement the methods, both of these, and this one, right, I want to remove these again. Avoid those, a bit annoying. This one should return an instance of that or an instance of this one, so I need these two. Let's create those. I'll do the uppercase first. We say server, I create a package here, uppercase, just to keep my functionality separate. It's bit overkill perhaps. We have uppercase server, and this one implements the upper, oh, I cannot call it that. Well, I shouldn't, I should call it uppercase server impl, because I also have an uppercase server interface. Right, and we must implement the methods, and here we can just again remove this part, and I can return a string to uppercase like that. Now I must remember to do the exporting of the object, so I need a constructor, and in here we say unicast remote object export object this and 0 for the default port, and yeah, we'll just add it there. Okay, I also need my lowercase and not there, upper and lower server lowercase, and we'll do something very similar. Lowercase server impl implements lowercase server. I need to implement the methods. I remove this one. We return a result to lowercase. I need my constructor to export the object, unicast remote export object this and 0, and here we just add exception. Yeah. Okay, and then my server implementation here can return a new uppercase server impl like that, and maybe we'll actually do that. And here we return a new lowercase impl, and I will actually add that. Okay. Yeah. So I have now the functionality of my server, more or less. My server can return instances of uppercase or lowercase. And let's just fix the run server part. It's no longer uppercase, it's a server interface. Yeah. And that's it. Okay. So that's all of my server side. I have my interfaces in place. I forgot to mark these as throws remote exception, but they do. All three interfaces extend remote, and they're implemented down here. So my functionality is split out. I have separate responsibilities here. Separation of concern. Let's do the client side. I have my client. I have my let's I can to uppercase something, and to do that we will say server. That's not the right one. Now we have a server impl, no, just server, like that, import class, and this one is a server, right? And we say server, and I can get the uppercase server, and here I can call it to uppercase with my argument. I could also, if I wanted to, I could not like that. I could get it up here, right? Oh, yeah, uppercase server like that, and I can create a field variable like that, so I can use this down here. So I could get it initially, or I could get it when I need it. I also need a, so I'll just copy this because it's very similar, like that. I think I did steal the wrong example because I don't want that one anymore. I don't want that. So there's no callback in my example here. I just remove that client, uppercase client, no callback. So that means the client doesn't export anything. This one doesn't throw that. And this one is to lowercase, and we say server get to lowercase server and to lowercase, and I can return this, and I can return that, and they should actually return something, string and string. Okay, so if I want to uppercase something, I will use the uppercase server. If I want to lowercase something, I will ask the server to get me the lowercase server. Right? I'll ask the server to return my lowercase server, which is this one, and the functionality is over here. So that will to lowercase something. Let us fix the run client. So first I want to say request. And that's a string request in next line, like that. And then we say, instead of that, we say if request equals lowercase. We do it like this, string result equal to client dot to lowercase with my line, else if request equals uppercase, result is equal to client to uppercase with my line, and finally we print out result may not have been initialized, else result is equal to did not understand request. Okay, I think that should do it. So let's try and run the server. And we run a client. That's a request. I will say uppercase. And I messed that up. Did not understand. We'll try again. Uppercase. Hello. And I actually get that back again. Lowercase. Hello. And I get a hello back again. So it seems that it's working, and I could run another client and show you that that's also working. But let's skip that. It's getting to be a long video, this one, because we still have some way to go. But now we have the separation of concerns, and if you use RMI, I suggest that you do this approach for your semester project, that you try it. Otherwise you'll just have one super large interface with all the methods. You can go all similar to all the else if going on in the socket version of this. So this one will split out the classes and makes it possible to work in parallel, so one student can work on this functionality, another can work on that functionality, and so on. Okay, so back to the slideshow. I do have a last point here. So we did these sending server objects, and now we have to talk about security. It's not something that we actually care about this semester, but it's something that we have to set up if you want to make RMI connect between two laptops. Then you have to set up the security, and the security reason is something like this. Let's assume that the RMI, we have the task list. You have seen a task list before. The RMI can create a task and add it, and it can get a task, and it can ask for the size of the server, and the server can then return a task, this task here. So I have a list of all the tasks, and I can return a task. So that means the RMI client, the stuff that I would put in my shared folder that they both need to know about is the interface. The RMI client and the server needs to know about the interface, and they also both need to know about the task. Right, so that's shared. Okay, what if someday I make on the server side I make something, apparently I call it a signed task, and it also takes a string of who made it, and it extends the task. Now, my RMI client doesn't have any reference to signed task, but if it does request a task at some point, it might actually get a signed task returned. So for the sockets, you would get some kind of unknown class exception thrown or something like that. But RMI is made in a both clever and unclever way, in that if the RMI task client receives an object of some type it does not know, it will ask the server to download that class file. So the client can download the class file of signed task from the server. And that's fairly clever, because then whenever I change something on the server, modify the class here by extending it, I don't need to update my client program. So there is a bit of separation going on, which is nice. But it also means that there might be some security risk, and I'm not a big hacker, so I have a bit of a difficult time coming up with a good example. But maybe I return some signed task to my client that will actually listen for all keyboard inputs, or it will run some kind of virus and shut down the client computer or whatever. And our security doesn't really prevent that, but it could. But I think the point is that you could risk connecting to something you're not entirely sure of, or something like that. I don't know. In either case, we have to set up some security. So that says something about what the client here is allowed to connect to. So that was what we call dynamic class downloading, and this is the error you will get if your class not found exception. That's it. Okay, so that's what you might receive. So the security, as I said, we don't really care about it, but we do have to set it up. So we just set it up and open everything and make it super loose and allow all of it. So there's a bit of a extra setup on the client side. When you run your main method, you can start by making this here, right? These few lines, and then you can start your client. So this just adds a security policy, and this is the name of this file. So you have to create a file with a security policy that indicates what are we allowed to do. And this is the name of that security policy, and then you have to set up a security manager. And I have found that sometimes you need the absolute path to the file, and sometimes this is enough if you put it in the right place in your project. And the thing that we put into the security policy, you can read all about it by Googling on the internet if you are interested. So we create a file with a name. I call it RMI policy here. Here the name was security.policy, or you can call it all.policy. And if you want to set some specific restrictions, you have some various tools. So you are allowed to accept connections to ports in this range, or you can connect to it, and you can accept in both. And here you can connect to connections in that range. So you can set up some specific restrictions, but as I mentioned, we don't really care about that. So you can just put this here, these lines in your file, and then you put your file here. So that's at the root of your project, RMI.policy. There used to be a screenshot for Eclipse, but we don't use that anymore. And so you have this file here, it contains this, and in your client program, on your client side, in your main method, you just put in these lines here, and that should work. So you probably don't need to run the exercises, because as you saw, I could run it just fine, but when you have to connect two separate computers for your project, then you need to do this. So let's just try it out and see if I can make it work, and if not, then I will just cut it out. So I'll just shut down that. Okay, so the RMI policy is security right at the root of the project. I create a new file, and I call it all.policy, and I just steal from the slide this part, grant all permission. All right, and let's do the simple one, uppercase return. On my client side, in the run client, I will start out by doing the and I will steal this piece of code here, see if that works. And it's not security, it's all, and then I have to import that one, and apparently PowerPoint has some different quotes than IntelliJ. Interesting enough. All.policy, like that. So I'm setting a system property. That's the target or whatever you call it, and that's the file. So this file references my file over here. And deprecated. I don't know, it doesn't really matter. Again, as I mentioned, we don't care about this. Security will be discussed on third semester, so there you can be interested. Let's see if it works. If it doesn't work, then I cannot connect. So it's fairly easy to check if this is set up correctly. Warning, that's probably, I don't know. So started, run client. Okay, I have connected to the server, hello. And was that? Okay, that's the one with the 10 seconds, and I get a response back. So this works. My security has been set up all correct, so that's great. That was easy. Okay, right. Another few slides, and then we are done with this video. So we have the security set up. You just give it all permission because we're not very worried about it this semester. You can investigate if you are interested, and you put it at the root of your project. Okay, so a few comments about sockets and versus RMI, because we have now seen both versions. For the sockets, we had to do a bit more manual work. We had to manually create so the light boxes here represents threads. So we had to create our own threads, and we have to do the else if going on over here, and similar potentially on the client side, depending on how you write it. So it's a bit more low level, right? There's only one bridge. But it's also more clear what's actually going on, and sometimes that's the benefit. For the RMI, we don't really see the threads. They are sometimes at least there, but we can just call methods, and it looks like we're calling it directly. So it's a bit, I think, more intuitive to work with, but my experience is that my students find it actually a bit more difficult, and maybe that's because it's more hidden what's going on. But once you get used to it, I think RMI is fairly easy. Okay, so outside of LAN, RMI is a bit more troublesome to set up. There's more port forwarding and firewall setup that you have to do. So usually sockets are easier on that, in that regard, because RMI is more, you can do more things with the dynamic class downloading for that, and those kind of things. So it seems to be a bit more restrictive. I find it a bit more intuitive because it's just like calling more normal methods. So that's a good thing, because it seems easy to work with, but it's also a bad thing in the way that it's not always clear whether you are actually calling a method on a local object or a remote object. And if it's a remote object, then you should not call methods as often, because that will slow down your program. Maybe not by much, but all this networking traffic back and forth will potentially cause a slowdown in your program. So if it's not clear whether you're calling a local or remote method, then that could lead to problems. One of the benefits is that we have these multiple bridges, as I talked about. You can call methods directly on the server, and you can create multiple server instances, like the upper and lower case example. So you have more flexibility, and it's easier to split out the functionality, and therefore also the work between students in a semester project group. Sockets are easier to use outside of your local area network. You do need to handle some things more explicitly and manually, like the threads and the if-else statements. You have some more connection handling, and you have to create the streams and send objects back and forth. In Java, it's a bit easier than in C#. So in that regard, we are lucky. On first semester, you will see the difference. You have to be a bit more careful about your client-server protocol, making sure you return and make the callbacks correctly. So that might be a bit more difficult to set up. And we just have that single bridge, so we're needing the if-else statements, and I haven't found a good way around that. I have tried to Google, and I have tried to ask on Stack Overflow without any relevant input. I've seen a few variations of these, but not really anything super clever. So maybe that's in your project, I don't know. Okay, so there are a few differences. You may think that for your semester projects, that because your project should work outside of local area network, because it's something like it's needed by Horsens or something more globally, that you then think you need to use sockets, but we don't really care about that. So for your project, it's okay to use RMI, whether it's actually real world relevant or not, but you just pick whichever you prefer. Okay, that's all for this video. It's gotten pretty long, so I hope you made it through, and thanks for watching. I will again put all the code on GitHub. So see you next time.